I am Srikanth from CSM department, Marri Laxman Reddy Institute of Technology and Management. My subject is cloud computing. Today we are discussing about the topic computing paradigms. Course outcome. The course outcomes are the students will be able to understand about different computing paradigms and know fundamentals of cloud computing and the characteristics of a cloud computing. The understand the ways in which the cloud computing be programmed and deployed. And next one is know about different cloud service providers. Now, the lecture agenda of this session. First one, high performance computing, parallel computing, distributed computing, cluster computing, grid computing, next biocomputing, mobile computing, quantum computing, and optical computing, and last one is nano computing. The computing paradigm. Now, the first topic is computing paradigm. Basically, what is the computing paradigm? A computing paradigm is a fundamental model, approach, or style or organizing, designing, and performing the performance computing to solve problems. The definition: the consistent approach to computation, data organization, and design and style is the purpose of computing paradigms to solve problems efficiently by providing a standard set of practices. Next, evaluation. Evaluation of a computing paradigm. Paradigms changes the based on technological advancement and such as moving from centralized systems to distributed systems. The focuses of the computing paradigms, the performance and scalability and efficiency and innovation. Next, the high performance computing. High performance computing uses cluster of powerful processes working in parallel to solve the complex, massive or time critical computational problems at speeds of millions of trillions of faster than traditional computers. It integrates advantages hardware, CPU and GPU, high speed networking and storage with specialized software to run simulation, modeling, and AI tasks. Used in weather forecasting and climate modeling and space researches. Example for this high performance computing is supercomputers like Cray and Summit. Parallel computing. Parallel computing is nothing but is a method of where large and complex problems are broken into smaller tasks. It executed simultaneously across multiple processors to boost speed and efficiency. Benefits of parallel computing: reduces execution time and saves resources by using multiple processors simultaneously. Here we are seeing the parallel computing. This is the server, and these are databases, and these are clients or users. The clients are using one server and different types of databases. Databases can store the data or tasks, some information about. Okay. Next, the types of data parallelism. First one, data parallelism and task parallelism. Next, cloud computing. The need for cloud computing. Cloud computing is essential for modern businesses offering on-demand access to computing resources over the internet, eliminating expensive upfront hardware cost. For reasons for the need for computing, cost efficiency, it is scalability and flexibility, and accessibility and remote work, disaster recovery and data safety, and speed and innovation, and global reach and low latency. And last one, advanced technologies. Next topic is cluster computing. What is mean by cluster computing? The cluster computing is powerful distributed architecture where multiple independent computers known as nodes. Here, the each computer works as a node. Okay. Here, the computer each and every system, each and every computer works as a node, and it has one single root node like this one. Okay, group of connected computer working as one system. Okay, these group are connected systems are working as one system. These group of connected systems are connected with the network. Okay, high speed network. Each computer is called as a node, and node share workload. These nodes are sharing total workload. Okay, next, the providers high availability and fault tolerance. Grid computing. Grid computing is a distributed systems that connect a geographically dispersed and heterogeneous computers to act as a virtual supercomputer, enabling collaborative processing of massive complex tasks. By pooling ideal resources, it provides cost efficient, high performance computing for scientific simulations, financial modeling, and data analysis. Uh, the grid computing used for large scale scientific projects and data intensive tasks. For example, this is the main example of grid computing. Next, biocomputing. Biocomputing or biological computing. This is an interdisciplinary field that uses biological components like DNA, proteins, and cells to perform computational tasks. I'm aiming to create and simulate or mimic living organisms. Here, the biocomputing uses biological molecules for computation, and DNA used for store and process the data, and highly efficient, and still it is in research stage only. Potential applications are first one medical diagnosis and genetic analysis, and mobile cloud computing. Mobile cloud computing combines cloud computing with mobile technology to deliver applications, data storage, and processing power directly to mobile devices. Reduces reliance on the devices on own hardware. This infrastructure enables high performance apps, seamless data synchronization, and increased battery life for users. Here we are seeing the picture cloud mobile cloud computing. This is the cloud, and here is the users, and this is the devices. Next one is quantum computing. Quantum computing is an emerging technology that uses principles of quantum mechanisms, especially superposition and entanglement, of solve a complex problems far beyond the capability of uh, classical supercomputers, using qubits that can exist in multiple stages simultaneously. Here we are using qubits instead of bits. Okay, these systems offer exponential speed up for optimizing cryptography and molecular simulation. Based on quantum mechanisms, here we are using qubits instead of bits, performs multiple calculations at once, extremely fast for specific problems. Next, applications of quantum computing is cryptography and drug discovery. Next, optical computing. First of all, we have to know about optical computing or photonic computing. Photonic computing uses photons. Sorry. Optical computing. Here we are know about optical computing or photonic computing. Photonic computing uses photons. Photons means light beam. Okay, from lasers and diodes rather than electrons. Electrons means electricity, to perform data processing, storage, and transformations. Here, the optical computing uses light means photons instead of electricity. Okay, we are here. Optical computing uses light instead of electricity, and faster data transformation and low heat generation. Okay, next, used in fiber optic communications and high speed data processing. Still, it is under development only. Okay, next, nano computing. Nano computing is referred to the design and use of extremely small and nanoscale devices to perform computing tasks. Often utilize molecular, mechanical, and chemical or quantum technology. Okay, next, count on computing at nanometer scale and uses nano-sized components and extremely small and fast, and the applications of nanotechnology or nanocomputing, medical nanorobots, and advanced electronics. Next, emerging technology. Okay, thank you.